In July 2022, 3 European bison were released into an English woodland. Within hours, they began tearing it apart. They pushed through walls of vegetation, stripped bark from living trees, crushed young plants beneath their bodies, and rolled across the forest floor until leaves and roots gave way to open soil. It looked like destruction. Then light reached ground that had been trapped beneath the canopy. Insects appeared in the bison dung. Seeds began finding space to grow. Trees damaged by the animals started becoming habitat for beetles, fungi, birds, and bats. The bison had not been brought into the forest because they needed rescuing. They had been brought in because the forest did. West Blean and Thorndon Woods lie near Canterbury in southeast England. From a distance, the woodland appears healthy. Tall trees form a thick green roof. Leaves cover the ground. The entire place looks old, peaceful, and untouched. That appearance hides the problem. A forest can contain thousands of trees and still be losing life. When the canopy closes completely, very little sunlight reaches the ground. Flowers disappear first, then grasses and shrubs. Insects lose the plants they depend on, birds lose the insects, and bats lose the open spaces where they hunt. The trees remain, but everything beneath them becomes simpler. The forest slowly turns into a green shell. British woodlands were not always left to grow this way. For centuries, people cut trees, collected firewood, grazed animals, harvested timber, and opened paths through the vegetation. Many of those practices damaged forests when pushed too far, but they also created something wildlife needed. Disturbance, a branch fell, a tree was cut, an animal passed through. Light entered the opening, plants competed for the new space, and different habitats formed beside one another. Modern conservation workers can imitate that process. They cut clearings, remove dense scrub, leave deadwood, and stop the canopy from sealing the ground in darkness. The problem is that the forest never stops growing. A clearing opened this year begins closing almost immediately. Shrubs return. Young trees rise. Branches spread into the gap. The crew eventually has to come back and open it again. One intervention becomes permanent maintenance. Across hundreds of hectares, that means people, machinery, fuel, planning, and money repeated year after year. The workers can decide where a tree should fall. But the result still follows a human schedule. The woodland needed disturbance that never followed a schedule. It needed something strong enough to reshape the forest every day, unpredictable enough to create irregular habitats, and alive enough to respond as the woodland changed. It needed an animal weighing nearly a ton. European bison are the largest surviving land mammals in Europe. A large bull can stand close to 2 meters at the shoulder. Yet the animal is not simply a European version of the American plains bison. Its body is built differently. The European bison has longer legs, a less massive front end, and a higher head position suited to browsing as well as grazing. It can move through woodland, eat grasses and leaves, strip bark, break branches, and force its body through vegetation that blocks smaller animals. Every movement changes something. When a bison pushes through dense scrub, it does not create a clean path. Branches snap at different heights. Some plants are crushed while others survive. Openings appear without forming the straight lines left by a machine. Sunlight enters those openings. Plants that could not survive under the closed canopy suddenly have a chance. Some grow in full light, others remain in shade. More insects can use the woodland because the woodland now contains more than one condition. One animal has begun creating several forests inside the same forest. The trees suffer as well. A bison may place its horns or forehead against a young tree and push. Smaller trees bend. Some break, others are uprooted completely, to anyone trying to protect every tree. The behavior looks harmful. But a healthy woodland is not a collection of perfectly preserved trunks. When a tree falls, it opens the canopy. Its roots pull soil from the ground, creating a pit beside a mound of exposed earth. Water collects differently. Seeds land on surfaces that did not exist before. The fallen trunk begins holding moisture and slowly breaks down. Fungi enter the wood. Beetles follow. Birds search the bark for insects. Small animals shelter inside cracks and beneath the trunk. The death of one tree creates hundreds of opportunities. A standing tree can be just as valuable after it dies. When bison strip bark, they expose the wood beneath it. If enough bark is removed around the trunk, the tree may weaken or die while remaining upright. Foresters call this standing deadwood a snag. Woodpeckers can carve holes into it. Bats and birds can use those holes later. Beetles lay eggs beneath loose bark, and fungi begin breaking the trunk down while it is still standing. Those organisms are not surviving despite the dead tree. They are there because of it. For decades, people often removed dead and damaged trees because they looked unsafe, diseased, or untidy in heavily managed forests. That removed one of the most important habitats from the system. The bison puts it back by injuring trees. Humans might have tried to protect. Important as decay wood is for the forest, the bison's most useful work may look even less impressive. Bison wallow. They lower their enormous bodies onto the ground and roll from side to side, grinding leaves, plants, and roots beneath their shoulders. Their hooves tear into the edges as they stand and move away. The finished wallow can look like nothing more than a patch of ruined earth. That bare soil is rare inside a woodland covered by leaves and vegetation. It gives pioneer plants a place to germinate without immediately being smothered. Insects that need exposed ground can use it. Rain can turn deeper wallows into temporary pools. A bison does not know which species needs the opening. It creates the opening anyway. Then it leaves dung behind. Dung beetles arrive to feed, breed, and pull pieces below the ground. Fungi grow through the waste. Nutrients that were locked inside plants and carried through the bison's body return to the soil in another form. The dung becomes food. The beetles become food. Birds and small mammals arrive for the insects. A pile of waste creates another chain of life. Grazing adds a different kind of disorder. Bison do not cut every plant to the same height. They eat some species more heavily than others. They graze in one place, browse in another, and pass through areas without touching them. The result is a patchwork. Short vegetation sits beside taller grass. Open ground sits near shrubs. Young trees grow beside deadwood. Sunlit gaps interrupt heavy shade. A machine can clear a large section quickly. A bison creates thousands of small decisions without following a plan. That difference matters because wildlife does not all need the same forest. A butterfly may need flowers growing in sunlight. A beetle may need decaying wood. A bird may need dense shrubs for nesting, but open ground nearby for feeding. A bat may need old trees for shelter and clear flight paths beneath them. A woodland made uniform, for one species may become useless to another. The bison creates mess because life needs choices. The first animals released at Blean were 3 females, an older matriarch and 2 younger cows. Britain had no modern experience managing a free-roaming herd of European bison, so the animals entered a carefully controlled project. They received no instructions about where to push, what to eat, or which trees to damage. Their behavior began immediately. The animals opened roots through dense vegetation. They stripped bark and created wallows. Rangers found dung beetles working through their droppings. The forest responded to an animal behavior that had been absent from the site. Then the project produced a surprise. 2 months after the females were released, the matriarch gave birth. She had arrived pregnant without the team knowing it. The calf became the first bison born in wild conditions in modern Britain. A bull joined the herd later, that year after paperwork delayed his arrival from Germany. The next calf carried a deeper significance. It had been conceived and born inside the woodland. The project was no longer holding a group of imported animals. The forest was producing its own herd. That success becomes more extraordinary when compared with what happened to the species a century earlier. European bison once lived across much of Europe. As human populations expanded, forests were cleared and the animals were hunted into smaller areas. Their size made them powerful, but it also made them valuable. A single animal provided an enormous amount of meat. Hunting became easier as weapons improved, and the bison lost more habitat. By the beginning of the 20th century, the remaining wild animals survived mainly in isolated populations. The First World War pushed one of the final strongholds into disaster. Soldiers, poachers, and hungry local populations killed bison in and around the Białowieża forest. The last wild animal there was killed shortly after the war. A second population survived in the Caucasus. In 1927, the last wild European bison was killed there. The species still existed, but nowhere in nature. Only a small number remained in zoos, private collections, and animal parks. Conservationists began identifying which animals could reproduce without mixing the species with other bison. The usable population narrowed to an almost impossible number. Every European bison alive today descends from just 12 founding animals. 12 bodies carried the future of Europe's largest land mammal. Conservationists created a breeding record to track their ancestry. Animals were moved between collections. Pairings were chosen carefully because the population could not afford to lose genetic diversity it barely had. The project lasted longer than the lives of the people who began it. In the 1950s, captive-bred bison were released into Białowieża forest. More herds followed across Europe. The population slowly grew from dozens to hundreds, then thousands. The animal had passed through extinction in the wild and returned. That rescue created a new problem. Saving a species inside breeding centers is only the first step. Large animals need large landscapes, and European bison cannot simply be released anywhere. Humans find an empty field, they eat heavily, they damage trees, they cross boundaries, they can injure people when threatened, and a bull may weigh as much as a small car. Europe is divided by farms, roads, towns, fences, and property lines. The animal survived extinction only to return to a continent with little room left for it. Blean offered a different role. The bison would not merely occupy the woodland, it would work on it. This reverses the normal conservation story. Usually, people repair a habitat, so an endangered animal can survive there. At Blean, an endangered animal was introduced because its behavior could repair the habitat. The bison was not only the patient, it was part of the treatment. The work is not being done by bison alone. Cattle, ponies, and pigs have also been introduced because each animal affects the woodland differently. Pigs disturb soil with their snouts. Ponies graze vegetation in their own pattern. Cattle browse and trample areas the bison may use differently. That combination is important. No single animal maintains an entire ecosystem. Nature works through relationships, competition, movement, death, waste, and disturbance happening at the same time. The bison stands out because its size allows it to perform work no smaller animal can match. It can physically change the structure of the woodland. That is also what makes the project difficult. Britain has very little land that is not crossed, owned, farmed, visited, or bordered by human activity. Public paths run through many woodlands. Nearby landowners need to know that a 1-ton animal will remain inside the project area. The bison are therefore free roaming within a large enclosure, not across the open British countryside. Fencing controls their range. Rangers monitor the herd. Special bridges allow people to cross above routes used by the animals. This is not wilderness without humans. It is an attempt to give natural processes more freedom inside a landscape. Humans still control. Even within those boundaries, the bison challenges what people expect conservation to look like. Many people imagine a healthy forest as tall trees, an unbroken green canopy, and a clean path through the middle. The bison produces the opposite: mud, broken branches, torn bark, fallen trunks, dung, holes in the canopy, and paths forced through shrubs. Its good work looks like vandalism. That reaction exposes a deeper contradiction. People often say nature should be left alone, but the landscape they want left alone is usually the landscape they find beautiful. When animals make it rougher, darker, muddier, or less convenient, tolerance disappears. A bison does not care whether the woodland looks preserved. It responds to food, shelter, weather, other bison, and the shape of the land. Its decisions may damage individual plants while creating better conditions across the wider forest. The difference is one of scale. Humans see the wounded tree. The forest receives the sunlight, fungi, insects, cavities, roots, and deadwood that follow. The full results at Blean will take years to measure. Trees decay slowly. Plant communities change across generations. Birds and insects respond to habitats that may take decades to form. The project's strongest claim is not that a few bison have already solved every problem in the woodland. It is that the missing process has begun again. Bison born at Blean are growing up inside the forest. They are learning where vegetation is thickest, where bark is easiest to strip, where the ground remains dry, and where mud forms after rain. The herd has continued breeding, producing multiple generations. Some animals from Blean have already been moved north to help establish another breeding herd in Cumbria, where they are being used in the restoration of a much larger landscape. The experiment is spreading. An animal reduced to 12 founders is once again reproducing inside British woodland and saving the forest in a way human conservation could not.